In this video, we are going to solve a problem on centripetal force. A stone is attached to the end of a string. The stone is then spun in a vertical loop of radius r. So we have got a vertical loop here in which the stone is being spun. The first part, derive an expression for velocity at the top of the loop in terms of r, m, g and tension force. That's our first part. And the second part, if the speed of the rock at point P is v equal to root of 6 rg, what is the magnitude of net force exerted on the rock? So first let's look at the first part, derive an expression for velocity at the top of the loop. So top of the loop, let's say here at point Q. So at point Q we can see that there is a string, so obviously there will be tension force which is pulling it downwards. Also there will be weight of the stone which is going to pull it downwards, that is mg. So the net force which is acting towards the center of the circle, which we call as centripetal force, is equal to mg plus t. So what is Fc? It's the net force, not the net force in the sense that all the forces together. It's a net force acting towards the center. There might be forces which are not acting towards the center, but if you want to check for centripetal force, you have to look at the net force which is acting towards the center of the circle. And in this case, it's the tension and the weight of the object. We also know that Fc is equal to mv square over r. That's the formula for centripetal force. So we can write mv square over r is equal to mg plus t. We want to get an expression for velocity, so we have to keep velocity on left hand side and take everything else on the right hand side. So mv square is equal to r mg plus rt. Then I'll divide both the sides by m. I'm going to get this as v square equal r mg plus rt over m, and I can also further separate m with each expression. So r mg over m plus rt over m. This m can be cancelled out. So v, I have to take square root on both the sides. So square root rg plus rt over m. So that's the expression for velocity for the stone at the top of the loop. Next, it says if the speed of the rock at point P. So look at point P. So this was Q in our previous part at the top of the loop. But now we are not looking at the top of the loop. We are looking at point P. So at point P, obviously there will be a force acting towards the center of the loop, which will be the tension force because the stone is attached with a string. And there will be a force of gravity which is going to act vertically downwards. It's asking us what's the magnitude of the net force, and we can clearly see that there are two forces acting, one towards the center and one because of the force of gravity. So net force F net will be equal to square root, because they make an angle of 90 degree, that should be mg square plus t square. Now we don't know what is T, tension in the string, but we know that tension is the centripetal force acting on the stone at point P, because at point P the net force acting towards the center is only the tension force. So I can also replace Fc by mv square over r. So tension will be equal to mv square over r, where v is root of 6 rg. So m root of 6 rg whole square over r. So t will be equal to m 6 rg over r will be cancelled out. I'll get that as 6 mg. So we will substitute that back into the formula for F net. So mg square plus 6 mg whole square. So we have got this as, so 6 square is 36, and here we have got 1, nothing, no number means there is 1 there. So 36 plus 1 will give you 37 mg square. And if you open up the square root, we'll get root of 37 mg square can come out as mg. That's the value for, or that's the expression for F net.